Yes, I think I'm recording now. Yeah, thank you. All right, guys. So yeah, so introduction to random variables and probability distributions. So first, I guess I will start with the definition of random variables. I'm going to try to explain what I mean by random variable and probability distribution. And then I guess we're going to have a couple of examples, all right? So let's start with the definition of random variable. Okay, so random variable. So this is a definition of random variable. So first, a random variable is actually a quantitative variable. So quantitative variable, guys, it's a variable which can be expressed as a quantity, right? So a quantitative variable x. Okay, again, what I mean by quantitative variable, that's a variable that can be expressed as a quantity. So it's a random variable, is a random variable if the value that x takes on in let's say an experiment or an observation in a given experiment or observation is, so the value that x takes on is actually a chance or a random outcome, is a chance or a random outcome. Okay, so what I'm saying is that the value of x can be just a random, some random outcome. Okay, it's not fixed. And then we actually distinguish between two kind of random variables. We have a discrete random variable and a continuous random variable. So for discrete random variable, the discrete random variable actually can take on only a finite number of values. So we have two kinds of random variables. So there is a discrete random variable. So a discrete random variable can, so when it's discrete, then so the variable x can take on only a finite number of values Okay. So when I say finite number of values, guys, I mean, for example, integers or rationals. Okay, so for example, integers or rationals, etc. Okay, so it can take on only a finite number of values. And then there's this is discrete. This is what I call discrete random variable. Okay, so when you have a finite number of values. Now there's a continuous random variable. Oops. So there's there is a continuous random variable okay, and the continuous random variable actually can take on any value in an interval. Okay, can take on any value in an interval. So, for example, an example of discrete random variable. So examples. So examples. So for discrete random variable, so let's say X is, the number of students in the class. Okay, X, that's the number of students in the classroom. Okay, so number of students, well, number of students is just a finite number. Okay, so for example, you say the number of students 30 or 31 or I don't know, 20 or, it's just some finite number. Okay, so this is this number. So this number of students, so the number of students is finite. Number of students. And so number of students, it could be, of course, could be 4, 5, 6, 7, etc., or 20, or good evening, Candy. Yeah, so number of students can be, it's a finite number. It's just a finite number. Okay. So then this variable x is discrete, and x is discrete. Okay. So that's for the number of students. Now, let's say x is the time x is the time it takes. So x is the time it takes to, let's say, it takes to get on, say, on campus. Okay. So the time, guys, the variable time, it's not a discrete, it's not a discrete value, because, the time could be, I don't know, let's say you can say, well, it's 10 seconds or 10.5 seconds or, so it can be a decimal, right? It can be a real number. It's not discrete. It's not just an integer, right? It's not just a whole number. The time, it can be a decimal, right? So then in this case, we say that the time is actually a continuous variable, because it can be any real number. So the x, the time can be any real number. It's not just the time. It's not just some an integer or a whole number. So it can be with a decimal. It can be a decimal, right? So it can be any real number. So then x is continuous. Okay. So again, by finite number, I mean this by discrete, I mean like the value of x is gonna be just a a whole number, basically an integer. Okay, so discrete is like x is gonna be just a whole number. And when I say continuous, I mean that the value of x can be can be any other number. It can be x can be like a decimal or etc. So it can be decimal. X can be decimal. Okay. So that's the difference between discrete and continuous random variable. All right. So now before the next example, guys, I'm gonna just so this is the definition of discrete. Sorry, the definition of random variable. Now, what's the definition of a probability distribution? Well, so we're gonna assign to each random variable a probability. Okay, so what I call a probability distribution is just an assignment of probability to each value of the random variable. And no problem, Aileen. Thank you for letting me know. Thanks. So yeah, let me define the probability distribution, and then we'll have more examples. So probability distribution, it's just an assignment of probability to each value of the random variable. So probability distribution this is the definition of probability distribution. So it's just an assignment of probability. So a probability distribution is an assignment of probability well, when you have a discrete random variable, then you're going to assign to each distinct value of the discrete random variable a probability, right? So when we have a discrete random variable, so we're going to assign a probability to each distinct value of the discrete random variable. Okay, and let me just say here, guys, a remark: the sum of all the probabilities is going to be equal to 1. And we're gonna have examples in a second. So the sum of all the probabilities is equal to 1. Okay. And when you have like a continuous random variable, you're gonna assign a probability to each interval of values. So probability distribution is an assignment of probabilities. So when you have a continuous random variable, so you're gonna assign a probability to each interval of values of the random variable. So to each interval of values of a continuous random variable. Okay. Anyway, so this is just the definitions, guys. So let me just explain all these definitions with a couple of examples. All right, so first example. Example 1. All right, so yeah, so let's say we're gonna measure boredom tolerance. So we measure we're gonna measure, let's say, boredom tolerance. Okay, and let's say we have like, I don't know, let's say we have like there are like 7 boredom levels. So 0, 1, 2, 3, 4, 5, 6 boredom levels, and 6, this is the highest, let's say, tolerance for boredom. So 6, this is the highest level. So this is 6, let's say this is like the highest tolerance for boredom. Okay. Again, guys, we are measuring boredom tolerance, right? And we have like 7 levels from 0 to 6. And 6, that will be like the highest tolerance for boredom. Okay. I guess I will be in level 3 or 4. Anyway, so there's this boredom test taken by, let's say, 20,000 people. Oops. So there's this boredom test. Okay, taken by let's say 20,000 people. Okay. And so let's say the results are the following. The results are so we have, let's say, this is a score here, or the level. So let's say this is the level. And here, this is a number of people. Okay, so let's say, for example, we have 1,400 people with 0 boredom level. Then we have, let's say, 2,600 people with the boredom level equal to 1. Then let's say 3,600 with boredom level equal to 3. So again, we have in total 20,000, right, people. So 1,400 with boredom level equal to 0, 2,600 with boredom level 1. Sorry, 2. I forgot 2 here. Sorry. This is supposed to be 2, boredom level 2. And then boredom level 3, let's say we have 6,000. All right, boredom level 4, we have 44,000. Then we have level, of course, 5 and 6. I don't have enough space, guys, so I'm gonna just move to the next line. So here, number of people again. So here, boredom level 5, and we have 1,600 with boredom level equal to 5, and then 400, just only 400 people with boredom level equal to 6. Okay. So let's say X is the boredom level. The variable X, so let's say X is our variable, and it's equal to the boredom level. Okay, this is our variable. So X is our variable. This is our variable. It's given by the boredom level. Okay, so how many boredom levels? We said we have like 7 boredom levels, right? From 0 to 6, from 0 to, as you can see here, from 0 to 6, there's like, so we have like 7 boredom levels, right? So the boredom level here, guys, is just a whole number, right? It's just it's a finite number. It's a whole number, right? And so do you think X would be a discrete random variable or a continuous random variable? So remember, discrete means like the variable is given by some, a finite number, which is like a whole number or integer, okay? So like here in this case, X, it's just 0, 1, 2, 3, 4, 5, 6. So it's just a whole numbers, right? So in this case, X is a discrete, right? This is, so X, the variable X, in this example, the variable X, that's the boredom level, the variable X is discrete because right? Because it can X can take on only a finite number of values. So because X can take on only a finite number of values, a finite number of values. Okay, which are, so we said finite number of values, so it can take on like the value equal to 0, 0, or so X can be equal to 0, or 1, or 2, or 3, 4, 5, 6, 5, 6. So X can take on only 7 different values, right? So that's a finite number of values. So X can take on, in this example, it can take on only 7, 7 values, only 7 values, 7 different values. Okay, so that's why X here is a discrete. It's a discrete random variable. It can take on only a finite number of values, just whole numbers or integers. Okay. Make sense? So that's why X is discrete. All right, so now, so this variable X, which is the boredom level, so X can be equal to, 7 different values. So it's a discrete value or discrete random variable. And now what about the probability distribution in this case? So I'm gonna do this, then the probability distribution, guys, I'm gonna assign to each value of X a probability, right? So probability distribution. So now what do I mean by probability distribution? So we're gonna assign probability distribution. We're gonna assign to each value of X a probability, right? So we assign to each value of X a probability. Okay, that's what I mean by probability distribution. So that's an assignment of probabilities, right? Now, how do we do that? Well, For example, the first value of x is, or x equal to 0. It means that the boredom level is 0. So what's the probability that, for example, so what's the probability that probability of randomly choosing someone with boredom level equal to 0, of randomly choosing someone with boredom level equal to 0. Boredom level x equal to 0. Okay, so we are looking for the probability that x is equal to 0. Okay, that the selected person has boredom level x equal to 0. Right? Well, so how many people, again, to compute the probability, right? We need the frequency of the event. So we count how many people with boredom level equal to 0. Well, I mean, as you can see, I mean, you can check in this table, we have like 1,400, we have like 1,400 people with boredom level equal to 0, right? Now divided by the size of the sample. And the sample, I mean, we have like 20,000 people, right, in total. So that's 1,400 over 20,000. Okay, so the probability that x is 0, the probability that the boredom level of x is 0 is the 1,400, right? This is, again, this is the number of people with boredom level equal to 0. The number of people with boredom level equal to 0 over the size of the sample. Of course, we need to divide by the size of the sample, and the size of the sample, that's the total number of people, that's 20,000. So this is the size of the sample. So P of x equal to 0, probably that the random variable x, this discrete random variable x is 0, is, so 1,400 over 20,000. I think that would be in percentage, I mean, that would be 0.07, 0.07, right? Or 7%. Okay, 1,400 over 10,000, over 20,000, that will be 0.07. So that's 7%. Okay, so this is probability for x being equal to 0, right? Now, again, to find this probability distribution, we need to compute the probability for each value of x, right? For each value of x, but x can be equal to 0, x can be equal to 1, etc. We have 7 different boredom of levels from 0 to 6. So to find this probability distribution, we need to compute the probability for each value of x. Okay. For example, probability for x to be equal to 0, to be equal to 1, for example. Okay. So this is like, again, this is, this is a probability of randomly choosing someone with boredom level x equal to 1. Okay, so this is boredom level x equal to 1. So of course, to find this probability, we need to count how many people with boredom level equal to 1. So boredom level equal to 1, it's, we have 2,600 people with boredom level equal to 1 out of the 20,000, right? So that's 2,600. Okay, so this is 2,600 over 20,000, and that will be equal to, I think, 0.13. Okay. Okay, so to answer this question, guys, the probability distribution in this case would be, so my probability distribution, so the answer so the probability distribution is given by the following table. By the following table. So so here's my X, and the first row, and the second row, that's the probability of X. For example, we said if X is 0, if the boredom level is 0, then the probability that of randomly, choosing someone with boredom level equal to 0, it's right here. It's it's the 7% or the 0.07, right? So again, this is a probability of randomly choosing someone with boredom level X equal to 0. It's the 0.07 or the 7%. So here we're gonna have 7% or the 0.07. So this is 0.07. Okay. So again, guys, how I got this number, the 0.07, this is the probability, right? As you can see, this is the probability that of randomly choosing someone with boredom level X equal to 0. We have 1,400 people with boredom level equal to 0, divided, of course, by the size of the sample. We have, in total, we have 28,000 people, right? So that's 1,400 over 20,000, and that's how I got this 0.07. Okay, so let me just to remind you, I got this number by dividing, when I divided the 1,400 people with boredom level 0 over the 20,000. Right? Now, for X equal to 1, if my random variable, my discrete random variable X equal to 1, then the probability of X equal to 1 is given, as you can see right here, is the 2,600 over 20,000, right? That's the 0.13. Okay, so this is here, this is 0.13. Now, when X is 2, then the probability that X is equal to 2. So again, this number here, this 0.13, this is the probability that X is equal to 1. Right? So next, when X is 2, the probability that X is equal to 2, that will be the number of people with boredom level equal to 2 over, again, the 20,000, right? So that will be the 3,600 over 20,000. And so that will be equal to 0.18. Okay, so this 0.18, this is the probability that X is equal to 2. And that's the number of people with boredom level equal to 2. That's the 3,600 over, again, 20,000. Okay, etc. 3, if X is 3, probability that X is equal to 3, that's 6,000 over 20,000. That will be like 0.3. 4, and then we have 5, of course, and then we have 6. 4, we have 4,400, right? As you can see here, we have 4,400 people with boredom level equal to 4. Okay, 4,400 over the total number of people, that 20,000, right? And the answer would be 0.22. Okay, with the boredom level 5, that's 1,600 over 20,000. That's 0.08. And finally, for 6, we have 400, only 400 people with boredom level equal to 6 over 20,000. That would be 0.02. Okay, So this table, that's what I call the probability distribution. Okay, guys, so this table right here, this is what I call probability distribution. So for each value of X, you assign a probability of X. So for example, when I say my X is 4, so for example, so probability that X is equal to 4. Okay, so this is like the probability of, again, this is the probability of choosing someone, probability of choosing someone randomly, of course, someone with boredom level equal to 4. Boredom level equal to 4. Okay, so this probability is given by the 0.22. Okay, this number right here. So again, this table, that's what I call a probability distribution. So for each value of X, you assign a probability. Okay, does this make sense to you guys? All right, so now one more remark, guys. If you take the sum of all the probabilities of X, 0.07 plus 0.13 plus 0.18 plus 0.3 plus 0.22 plus 0.08 plus 0.02, and then the claim is that the sum would be equal to 1. It's always equal to 1. Okay, the sum of all the probabilities is equal to 1. Remark. The sum. So just to remind you, summation symbol, guys. This is called the capital sigma, right? This is a summation. All right, and what I'm saying is the sum of all probabilities of X. This is equal to 1. Always equal to 1. All right. So again, what I mean here is the sum. So this is like probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to 2 equal to 3 equal to 4, equal to 5. So we have 7 level of boredom levels. So 5. So the last level is the X equal to 6, right? So X equal to 0 probability is 0.07. X equal to 1, the probability is 0.13, X equal to 2, probability is 0.18. X equal to 4, the probability is 0.22. X equal to 5, probability is 0.08, and the last probability is 0.02, right? And what I'm saying is, did I forget anything here? Probably not. 1, 2, 3, 4, 5, 6, 7. I forgot one. What did I forget? 18. Oh yeah, the 0.3. I forgot the 0.3. So sorry. I forgot the 0.3. This is the probability when X is equal to 3, right? So yeah, the sum is actually equal to 1. Okay, so when we have a probability distribution, the sum of all the probabilities is supposed to be equal to 1. All right, guys. Before the next example, let me just say one more thing. Actually, we can graph a probability distribution. Okay, so the graph of probability distribution. Oh yeah, let me just say here, guys. I mean, sorry. I mean, this probability here, this probability of X, again, it's just, so this probability of X, it's the frequency over the size of the sample, which is, again, this is exactly the definition of relative frequency, right? That's exactly the relative frequency, okay? So this P of X, you know, this probability of X, this is just the relative frequency. Okay, it's the frequency over, remember, when you divide the frequency by the total number of your data values or total number of the, you know, the size of the sample, that's exactly the relative frequency. And remember, when we have relative frequency, you can draw like the corresponding histogram. Remember, we can draw like the histogram of the frequency, or if you want to display the relative frequency, you can also use the histogram. So yeah, so to graph a probability distribution, we're gonna use a histogram to display the probability distribution. So graph of probability distribution, sorry, too many BA. Yeah, probability distribution. Okay, so we're gonna use, to display this probability distribution, we're gonna use a histogram. So what I'm gonna do, guys, like in this example, so we're gonna have like a horizontal axis, all right? So this horizontal axis is supposed to represent the values of X, and there's this vertical axis, and the vertical axis actually represent P of X. Okay, but remember, just keep in mind, this P of X is just a relative frequency. So this is just the histogram of the showing the relative frequency. Anyway, so in our example, like the values of X can be equal to, you know, from actually from 0 to 6, right? The boredom level X, it goes from 0 to 6. So we're gonna need, so let's say here's my 0, 1, you know, 2, this is 3, 4, 5, and 6. Okay, that's the values of X, the boredom level. This is, again, this is just the boredom level. All right, and here on the vertical axis, we're gonna put the, you know, the P of X, or the relative frequency, right? The P of X. So P of X, where's the P of X? Yeah, here. So as you can see, the values of P of X, you know, the smallest value actually of P of X is, that is 0.02, and the largest value of P of X is 0.3. Okay, so yeah, you have like from 0.0 to 0.02. So let's say this is like 0.02, and then this is 0.05, 0.1, 0.15, you know, 0.20, 0.25, and then I'm gonna need the last one here, the 0.3. So, for example, to represent the P of X of the X equal to 0, boredom level X equal to 0. So as you can see, if my X is 0, the boredom level, if my boredom level X is 0, then P of X is 0.07. right? So 0.07. So what I'm gonna do, I'm gonna draw like, like a rectangle, and 0. So this 0, this is my x, right? So what I'm gonna do, I'm gonna put the 0 like in the middle of some interval, okay? And I'm gonna draw like a rectangle with the height equal to 0.07. So I need a rectangle with height 0.07. Okay, so here, so as you can see, this is here, this is like 0.07. That's the P of X of P of X equal to 0, right? The probability that X is equal to 0. For X equal to 1. So as I said, so you're gonna put the X equal to 1 like in the middle of your interval. So like here between these 2 points. And I'm gonna draw like a rectangle with height P of X equal to 1. P of X equal to 1 is 0.13, right? So when X is 1, P of X equal to 1 is 0.13, right? So we're gonna go with a rectangle with height equal to 0.13. So that will be probably somewhere right here. So yeah, as you can see, I mean, the height of this rectangle is 0.13. Okay, etc. So next, for X equal to 2, the P of X equal to 2 is 0.18. So I'm gonna put like 2 again, like in the middle of some interval, like this one here. And I'm gonna go with some rectangle with height 0.18. Okay, when X is 3, P of X equal to 3 is 0.3. So that will be this rectangle here. So this is where X is equal to 3, right? Again, the 3 is like in the middle here. Okay. Then for 4, it's 0.22. So 0.22. So here's my interval. 4 like is in the middle of your interval. And I'm gonna go up to 0.22. So that will be probably somewhere right here. 0.22. Right? I mean, this is like somewhere right here, 0.22. For 5, it's 0.08. So we're gonna go with some rectangle up to here. So this is my 0.08. And finally last, X equal to 6, the height is 0.02. So this is kind of very small rectangle. So this is my 0.02. Okay. Does this histogram make sense to you guys? Again, the values of X, as you can see, the value of X, like X equal to 0, here's X1, this is X2, 3, 4, 5, and 6. It's like in the, X is like in the middle of your interval, okay? Or the side of the rectangle. So let me just say, guys, because each bar is 1 unit wide. Like this bar here, you know, like this bar here, it's 1 unit wide. The area under the graph is going to be equal to 1. Okay, because remember the sum of all the probabilities is 1. So my claim is that the area under the graph here is going to be equal to 1. Okay, so just remark. So because the sum of the probabilities is 1, the area under the graph is equal to 1. So what I mean by the area under the graph is, it's actually, so what I mean by the graph is this. So this is like my graph. Okay, and I'm saying the area under this graph is going to be equal to 1. Any question, guys? So yes, so that's what I call the histogram of the distribution, or the histogram of the probability distribution. Okay. Yeah, let's do a couple of let's do at least one exercise. Okay. Then we're gonna of course compute this, because this is like a, you know, you have like a, you know, relative frequency. We can discuss actually the mean and the standard deviation of etc. But before that, let's do an exercise. Similar problem. Okay, so exercise. Okay, so X so X is going to be the number. This is the number, let's say, of number of professors in committees in the college committees. Okay. So we have different, of course, we have different committees in the college. So we have the following results. So the total number, of course, before the results. So the total number of committees in the college. So the total number of committees is actually 100. Okay, let's say, so in the college, let's say in the BCC, we have 100 committees in the college. And so, and we have the following results. In BCC. Okay. So we have X, and then here we have the number of committees. Okay. So we have 20 committees with only one professor in the college. With two professors, there are, let's see, yeah, there are 25. So there are 25 committees with two professors. We have There are so many committees in the college, I can tell you. Um, um, okay, and then let's say we have 5 committees with 3 professors, right? And then 30 committees with 4 professors. And finally, we have, so the total should be 100 committees. How much is that? Let's see. So far we have 80, right? So then there are 20 committees with 5 professors. Okay. So first question. So A, 1. So is the variable X, is it a discrete or continuous random variable? Okay, and then of course you have to justify your answer, guys. 2, you need to find, you need to find the probability distribution of X. All right, 3, you need to graph the histogram of the probability distribution. So graph the probability distribution. Right, 4, find what's the probability of let's say randomly, of course, selecting or choosing, selecting a committee with 2 or 3 professors. Hey guys, yes, so let's say you have, all right, so let's say you have 5-10 minutes to think about this problem. First, you have to say, well, if X is discrete or continuous. I guess the main thing here is to find the probability distribution and then to graph the probability distribution, right? And then 4, what's the probability of selecting a committee with 2 or 3 professors? All right, so yeah, so let's say you have 10 minutes to think about this problem. Let me just remind you guys, as I said in the beginning of the lecture, so we're gonna meet online this Wednesday. There's a heating problem in the campus. So all hybrid and in-person classes, they're gonna go online this week. I don't know when they're gonna fix the problem. We'll see next week, okay? I will keep you updated. So this Wednesday, it's gonna be online. So again, guys, the X, that's the number of professors in the committee. Yeah, so this X here, that's the number of professors in the committee. So this is very similar to the example we had. So next, I can probably give you an example. Probably you know that the x here is going to be a discrete random variable. I mean, I can probably give you next an example where x is not discrete. X is where x is a continuous random variable. I mean, so you can just see, you know, again, the difference between discrete and continuous. So after this, guys, we're gonna discuss the mean and the standard deviation of probability distribution. We learned how to find the mean and standard deviation of any of data values. But I'm gonna give you the formula for the how to find the mean and standard deviation of probability distribution. All right, guys. Does anyone need more time to think about this exercise? Okay. Okay. All right. So, okay. So let's do this. So for number one, is x a discrete or continuous random variable? First, x, the values of x. So what are the possible values of x? I mean, x can be equal to 1, for example, can be equal to 2 or 3 or 4 or 5. So as you can see, I mean, x can take on only a finite number of values, either 1 or 2 or 3 or 4 or 5. Okay, it's just a finite number of values. I mean, we have like 5 different values of x, right? 1, 2, 3, 4, or 5. That's a finite number of values. Okay. So then x, of course, is a discrete random variable. Okay, so yeah, so x is a discrete random variable because x, so x is discrete because x, can take on only a finite number finite number of values. So X can be 1 or 2 or 3 or 4 or 5. Okay, that's just five possible values for X, right? So X is 1, or X is 2, or X is 3, or X is 4, or X is 5. Okay, so only a finite number of values. So that's why X is discrete. Next, of course, guys, please interrupt me if you have any question, right? Find the probability distribution of X. So probability distribution, so we need to compute the probability for each value of X, right? So for example, number 2, for example, if you try to find probability that X is equal to 1. So what do we mean by P of X equal to 1, right? This is the probability of randomly selecting, of course, a committee with exactly one professor, Okay, so that'll be the frequency of the event. Frequency is how many committees with one professor. That's the frequency of the event. So how many committees with one professor? So as you can see, there are 20 committees with one professor, right? So there'll be 20 out of, so in total, how many committees? As I said, we have 100 committees in the NBCC. So that'll be 20 over 100, right? So this P of X equal to 1, this is 20 because we have 20 committees with one professor. With exactly one professor over, the total number of committees, right? The size of the sample, we have 100 committees, so over 100, right? So that'll be equal to 20 over 100, that's 1/5, and that's 0.2, which is 20%, right? This is 0.2 or 0.20, and so that's 20%. Okay, does this make sense to you guys? Now for P of X equal to 2, for example, I won't do all the probabilities because, if you understand how it works, then, yeah. So, you don't have enough time to do all the probabilities anyway. So probability of X equal to 2, that's the probability of randomly selecting a committee with exactly two professors. So the number of committees with exactly two professors, as you can see, we have 25 committees with exactly two professors, and we divide by the total size of the sample. So in total, we have 100 committees. So that's 25 out of 100 committees, right? With exactly two professors. So that's 25 over 100. That's 1/4, and 1/4, that's 25%, or that's 0.25. Okay, etc. So then so then the answer here to the probability distribution so we need this chart. So what X, and here P of X. So again, what we mean by a probability distribution is that you assign for each X the probability of X. So X can be equal to 1, we said, 2, or 3, or 4, or 5. Now, probability that X is equal to 1, we just computed, it's 0.20 or 0.2. Probability that x is equal to 2, we said it's 25% or 0.25. So this is 0.25. Probability that x is 3 is going to be just 5 over 100. So that's 0.05. So this is 0.05. 0 point, of course, here, 0.5. The probability that x is 4, that's 30 over 100. That's 0.30 or 0.3. 0.3. And finally, P of x equal to 5. That's 20 over 100. That's 20% or 1/5. So that's 0.2. Okay, so this is my probability distribution. For each x, you assign the probability of x. Any question, guys? So I hope you see how I got all these numbers, right? Now, we need to graph the probability distribution. So when I say graph probability distribution, I mean like the histogram of this probability distribution. Okay, so phi. So the graph is probability distribution. Okay, so it's just the histogram, of course. Here's my x. Here's my P of x. So my x can be equal to 1, 2, 3, 4, and 5. The values of P of x, as you can see, the smallest value of P of x is 0.05, and the largest value of P of x is 0.3, right? So we have like 0.05, 0.1, 0.15, 0.20, 25, and then 30, 0.30. All right, now when x is 1, the P of x is 0.2. So what we do is, so we take the interval with 1, so 1 in the middle of the interval. As you can see here, you see this blue interval? So 1 is the middle of the blue interval, right? And then we draw the rectangle with height equal to 0.2 or 0.20, right? So I'm gonna go up to 0.20, and here's my rectangle. Okay. Next, when x is 2, the probability is 0.25. P of x is 0.25. So take the interval with 2 in the middle of your interval, and I'm gonna go up to 0.25. So here's my 0.25. X is 3, the P of x is 0.05. So here's my x equal to 3 in the middle of my interval. So as you can see, phi is in the middle. And then we're gonna go up to 0.05. So it's just up here. For 4, it's 0.3. So we're gonna go up to, so here's my 4 in the middle of my interval. And we're gonna go up to 0.3. And finally 5 in the middle. And we're gonna go up to 0.2, which is up here. All right, so again, this is 1 right here, 2, 3, 4, and 5. Right? And yeah, so that will be my probability distribution. And again, guys, if you take the graph, so the graph of this probability distribution, the area under the graph is going to be equal to 1. Okay, so this is just a remark. The area, again, under the graph is equal to 1. Under the graph is 1. Okay, because the sum of the probabilities is equal to 1. But anyway, so that's the graph of this probability distribution. Last question, guys. Probability, where's number 4? What's the probability of selecting a committee with 2 or 3 professors? So 2 or 3, right? 2 or 3. So x is equal to 2 or x is equal to 3, right? So P of x, the number of professors, of course, is given by x. So the probability of selecting a committee with, so number 4, this is number 4. So yeah, the probability of selecting a committee with 2 or 3 professors. So that's P of x equal to 2 or x is equal to 3. Okay, so again, this is P of x equal to 2 or x equal to 3. This is a probability of selecting a professor, selecting a committee with 2 professors or 3 professors. So remember our addition rule, guys. Probability of A, so just to remind you the addition rule. So we discussed this last week, of course, probability of A or B. So we said it's probability of A plus probability of B minus probability of A and B, right? So in our case, A, so like x equal to 2, that would be A. So this is like A. And x equal to 3, that would be like B, right? A or B. So that's probability of x equal to 2, that's probability of A, plus, so this is like A, okay, or B, so plus P of x equal to 3, okay, so this is like B, minus, we're supposed to subtract probability of A and B, which means that x is equal to 2 and 3 at the same time, but this is not possible, right? So you cannot really have a committee with exactly 2 professors and exactly 3 professors. Okay, so a committee has exactly either 2 professors or 3 professors, right? So this P of A and B is just 0. It's not possible, right? You have either exactly 2 professors or exactly 3 professors, right? It cannot be both. So yeah, so so this is just probability of x equal to 2. Well, x is equal to 2. Probability of x is equal to 2 would be the 0.25, and x equal to 3. Probability that x is equal to 3 is 0.05. So that would be equal to 0.25 plus 0.05. So that would be 0.3. Okay, so that's 30%. Okay. Again, probability that x is equal to 2 would be this probability right here, right? And probability that x is equal to 3 is this one here. Okay. Okay. Any question, guys? All right. If there are no questions, Well, we can do one more example with like a continuous, continuous random variable. But instead, what I'm gonna do, I'm gonna discuss the mean and the standard deviation, and then probably I'm gonna give you like an example with a continuous random variable. Anyway, so let's discuss now the mean and the standard deviation of random variable. Okay, so now the mean, okay, the mean and standard deviation of a probability distribution. Okay. Of course, here, so for the mean, so for the mean, guys, the mean is gonna be a sort of a weighted average. Because you see here, so we have these values of x, 1, 2, 3, 4, 5, but this probability of x, this is like the weight of x. This is 0.2, that would be like the weight of x equal to 1, because there's 20% chance that you have a committee with exactly one professor. So this 0.2, this is like the weight of x equal to 1, or probability that x is equal to 1. Okay, so that the 0.2, that's the weight of x equal to 1. The 0.25, that's the weight of x equal to 2, because you have like 25% chance that a committee has exactly 2 professors. Okay, etc. So the mean here is going to be, so the mean of a probability distribution is actually, it's kind of, as I said, it's just a weighted average. Is a weighted mean or weighted average. Okay. So for a probability distribution, the mean, well, of course, here there's a notation in case we have like a population probability distribution or a sample probability distribution. So for a population probability distribution, the mean, it's denoted by, remember, for a population data, the mean is actually denoted by, mu. Okay, so this is here, this is mu. This is mu, mu. Okay, again, this is Greek letter. So this is a notation for the mean of a discrete population probability distribution. So this mean is going to be equal to the sum, of course, of x, the variable x, times, okay, p of x. As I said, this is sort of a weighted average or weighted mean. So this is our mean. Okay, it's just it's the sum of x times p of x. When you have a sample probability distribution, instead of mu, we use x bar. Okay, so for So for when we have a sample, probability distribution, we have, so the mean is just denoted by X bar instead of mu. Okay, it's just we use different notation. Mean it's X bar, but it's again, it's just the same formula. So it's sum of the X times P of X. Okay. Now for the standard deviation, so that's how we compute the mean. I'm gonna give you an example, numerical example in a couple of minutes, guys. Let me just give you now the formula for the standard deviation. So the standard deviation of a discrete population probability distribution So again, guys, the standard deviation S or sigma, depends if it's population data or sample data, measures, remember, it measures the spread of the data, right? Yeah, probability distribution. So this is, so in case of a population, so we have sigma. So this is sigma. Okay. Right, lowercase sigma. Okay. So standard deviation is going to be equal to. So this is equal to. So this is my standard deviation. So it's going to be equal to the square root of the sum of x minus the mean square times p of x. Okay, so you subtract x from the mean from the x, take the square, and then you multiply by this p of x, and then after you take the sum, you have to apply this square root. Okay. As I said, we're gonna do a couple of numerical examples, so don't worry about this. And if you have like a sample probability distribution, so instead of sigma, we're gonna have, we use S, okay? So for sample distribution, so again, this is the same, just the same formula, right? So the standard deviation it's denoted by S for the sample distribution. And again, it's just the same formula. So it's going to be like square root. And then we have the sum of x minus x bar square times p of x. So yeah, so this is going to be my standard deviation. All right, guys, so let's have a couple of examples or exercises. So example, let me just do an example, show you how to compute this, this standard deviation and this mean. All right, so an example exercise. Size. So we have the following. So X, this is the number of prisoners out of 5 who become repeat offenders. Okay. So we have the following table, following survey. So we have the following probability distribution. So X, this is P of X. So again, X is number of prisoners out of 5. So the maximum, of course, the maximum value of X is going to be 5. So it's going to go from 0 to 5. So it's either 0 out of 5, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, or 5 out of 5. Okay. Now for 0, P of 0, it's 0.237. So what does this probability mean? So this is a probability that 0 out of 5 prisoners that would become repeat offenders, right? So this is so P of X. This is the probability that X prisoners out of 5 become X prisoners become repeat offenders. Okay, so what we are saying with the 0.237, so there is like 23.7% chance that 0 prisoner out of 5 become repeat offenders. Okay, then there is, let's see, 39.6% chance that 1 prisoner out of 5 become a repeat offender. For 2, there is 26.4% chance. So that's 0.264. 3, that's 0.088. For 4, this is 0.015. And for 5, there is 0.001. So this is like saying there is 0.1% chance that 5 prisoners out of 5 become repeat offenders. Okay, I think this is exercise. This exercise is actually from the textbook. This is exercise number. I don't. Yeah, I know it's from the textbook, but let me see which exercise. If you have the textbook, where is it? Yeah, I think it's exercise 14, page 255. Okay, this is from the textbook. So this is exercise textbook 14, page 255. Sorry. All right. Anyway, so what we're gonna do, guys? We're gonna compute. I'm gonna show you how to compute. You know, the mean and the standard deviation of this distribution. So I'm gonna compute. So first, I'm gonna compute the mean. Mu. So what would be the mean here? So the mean, that will be the expected number. So when I say here the mean, that will be the expected number of prisoners who become repeat offenders. Okay, so the mean here, the average here. So the mean here, that will be the expected number or the average. So this is like the expected number of prisoners who become, or the average number of prisoners who become out of 5, of course, number of prisoners out of 5 who become repeat offenders. Okay. Expected or average number of prisoners who become repeat offenders. There's a question? Okay, probably not. All right, so how do we compute this mean? So we said it's the formula, guys. So mu, or the mean. So here we have a population probability distribution. Okay, because this survey covers actually all the let's say inmates in let's say in the US, for example. All right, so so your mean mu is going to be equal. So we said it's supposed to be x times p of x. All right, so what we do, so the mean or the average. So first value of x. So first value of x, as you can see, is 0, right? So we need to multiply 0 by the probability that x is 0. Okay, so we need to multiply 0 by the 0.237. Okay, so this is, so we have 0 times the probability that x is 0. So that will be 0.237. Plus, right? Because we have a summation here. This is this capital sigma. So we have like a sum, right? So where x, you know, x goes from 0 to 5. Now, when x is 1, the probability that x is 1 is 0.396, right? So that's plus 1 times the probability that x is 1. So probability that x is 1 is, of course, 0.396. Okay, when x is 2, the probability that x is 2, that's 0.264. So that's 2 times 0.264. Plus x is 3. The probability that x is 3 is 0.088. Plus x is 4. When x is 4, we have 0.015. And finally, when x is 5, that's 0 times 0.001. Okay. Here, guys, I think this is kind of a common mistake, but you need to be careful with the PEMDAS rule. So first, you need to multiply, right? I mean, multiplication comes before addition, right? So we have multiplication first, so we need to multiply first, right? So we need to multiply like, so this is equal. So first we need to multiply. So this is like 0 times 0.237, 0 times wherever is gonna be 0. So that will be 0 plus, then we multiply here, right? 1 times 0.396. Well, that's just a 0.396. Okay. So you need to multiply first, guys, okay, before the addition, okay? That's the PEMDAS rule. So next, we have like, where is it? Yeah, the 2. So you see here, this is 2 times, this is point, of course, 2 times 0.264, right? So that will be equal to, so 2 times 0.264, that would be 0.528, right? Plus, and then we multiply 3 by the 0.088. So that's the 0.264 plus 4 times 0.15. That's 0.06. And plus 5 times 0.001. That's like 0.005. Okay. So once you are done with the multiplication, then you can add. Okay. All right. So then the answer here, I think, if I'm not mistaken, I mean, if I'm correct, that will be 1.25, I think. So this is approximately, this is equal to 1.25. Okay, so our mean is 1.25. So what we are saying here, guys, is that, so we expect, or the average, so we expect that 1.25 prisoner out of 5 okay, out of 5 become repeat offenders. Okay, that's not bad. I mean, so we are saying like, I mean, it's 1.25. So it's like 1 prisoner out of 5 who will become a repeat offender, right? So again, this is the mean of our probability distribution. Any question, guys? How I got this one? I mean, this 1.25? Okay, now I'm gonna show you how to compute the standard deviation of this population, of this probability distribution. Now let's compute the sigma, the standard, compute the standard deviation. Okay, so sigma, the standard deviation, is supposed to be square root of, then we have like a sum of your x minus mu squared times p of x. Right, so yeah, so you need to be careful here, guys. I mean, I mean, the last operation is the square root. So forget about the square root for the moment, okay? So first we need this, x minus mu square times p of x. So, so let's do first. So step one, I would say first step one is to compute this sigma square. So sigma square will be the sum of x minus mu squared times p of x. And then the answer, the standard deviation, would be the square root of this. Okay, so let's, as a step, first step, we're gonna compute the sigma square, or the standard, or the variance, or the square of the standard deviation. So sigma square is gonna be equal to, so let's start with the first x. So when x is 0, right? So here's x is 0. So we need, so it's, so as you can see, it's x minus mu. So it's your value of x, like x is 0 minus the mean. So we have like 0 minus the mean. And the mean is, the answer we got in the previous problem. So that's the 1.25. So this is like 0 minus 1.25. And then there is a square, and then times p of x. P of x, x is 0. So p of x, that's the probability that x is 0. So what's the probability that x is 0? It's this, 0.237. So times 0.237, right? So times 0.237. All right, this is the first value, plus, next, x equal to 1. So x is 1 minus, x is 1 minus mu, the mean. Mean, we said it's 1.25 square times p of x. Probability that x is equal to 1. I mean, if you check the table, probability that x is equal to 1, it's 0.396, right? That's the probability that x is equal to 1, right? As you can see here from the table, probability that x is equal to 1 is 0.396. All right, so that's for x equal to 1. Now next, plus, of course, this is a summation. We have a sum, x equal to 2. So that will be 2 minus, again, the mean, or the average, square times probability that x is 2. That's 0.264 plus x is 3 minus the mean. And then you take the square times probability that x is 3. That's 0.088. X is 4. That's 0.015. And then x is 5. And that will be 0.001, right? So next, guys, what we do is we subtract, okay? So for example here, this is 0 minus 1.25. So there'll be a negative 1.25. So it's negative 1.25. And then there is a square times 0.237. Okay. Again, 0 minus 1.25, that's negative 1.25. Plus, you see, I mean, again, my advice for you guys, I mean, if you are not, you have you have always trouble with computations, is to go step by step. Next, 1 minus, again, this is like a PEMDAS rule. In the PEMDAS rule, we do the parentheses and then exponent and then multiplication, right? So we have, as you can see, we have parentheses. This is parentheses, right? So we do what's inside the parentheses, and then the exponent, the square, and then we multiply. And then last operation is the addition, right? Bump this rule. All right, next we have 1 minus 1.25. That will be minus or negative 0.25. I probably gonna go to the next line. So plus negative 0.25 square times 0.396 plus next 2 minus 1.25. That's 0.75 square times 0.264 plus 3 minus 1.25, that's 1.75 square times 0.088 plus 2.75 square times 0.015, and finally 5 minus 1.25, that will be 3.75 square times 0.01. Right? So we did the parentheses. Now we need to do the exponent, and then and then multiplication, and then the addition, right? So now let's do the square. Oops. All right. Oops. Sorry about that, guys. What's going on with my pen? Okay. Sorry about that, guys. Yes. Yeah, we are here. All right. Yeah, so we need to take the square, right, guys? So this is, for example, first square, we have negative 1.25, right? And then we take the square. Okay, so that would be equal to 1.5625, for example, times the 0.237, right, plus. So what I did here, guys, I compute the square of this thing here. Negative 1.25 times negative 1.25, that's the 1.5625 plus. And then you do the 0.25 square, right? That's 0.25 times 0.25. So that'll be equal to 0.0625 times the 0.396 plus, and then you have 0.75 square. So that'll be equal to 0. Oops, come on. Okay, I have a problem with my pencil. Okay, yeah, so 0.75 square is 0.5625 times 0.264 plus okay, and then yeah, and then the 1.75 square, right? That will be equal to, so 1.75 square, that will be equal to, oops. What's going on with this? Okay, oops. Yeah, all right, now it's working. 3.06 25 times the 0.088 plus, and then 2.75 square. This is like 2.75 times 2.75. So that's 7.5625 times 0.015. So I'm doing all these details, guys, because I mean, I need to show you at least one time how to compute this standard deviation, okay? I'm gonna do this just for one time, in this example, but of course, in the next, probably the next exercises, I'm gonna just give you the answer. Next, we have 3.75 square, so that'll be equal to 14, 0.0625 times 0.001. Okay. Now we do the multiplication, guys. So now we need to multiply. So for example, you multiply, 1.5625, 1.5625 by the 0.237, right? So that'll be equal to actually 0.37, okay, plus, so etc., guys. So you see, you multiply next like the 0.0625 by the 0.396. So that'll be equal to 0.02, I think, approximately 0.025 actually, plus, okay. Anyway, so etc. And so the answer, let me see the answer. So that will be equal to, the answer is actually, so the answer should be 0. Plus etc. here. So the answer should be 0.94, I think. Okay. And yeah, so then that's, again, this is actually our, sigma square, the square of the standard deviation. So this is my sigma square. Okay, and then in step number 2, so in step number 2, I can compute my so in step number 2, okay, I can compute my my standard deviation. So sigma, my standard deviation is square root of sigma square. That will be square root of this 0.94. And so sigma, the standard deviation, is going to be equal to 0.97. All right. Any question, guys? I mean, I hope you see how I compute this sigma square. Once you have the sigma square, then you have to take the square root. You apply the square root, okay? Is there any question, guys? Okay, all right. So yeah, so that will be an example how we compute the the mean and the standard deviation of probability distribution. So we're gonna have a couple of exercises. So yeah, next, so we're gonna have an exercise. Well, I guess probably we have like 5 minutes left. So yeah, probably I guess I won't have time to go over this exercise, but I'm gonna, I guess, solve this next time. All right, but let me, well, at least write down the exercise. So this is from, from the textbook. So this is actually exercise, I think 13. page 254 from the textbook. Anyway, so in this exercise, so we have this number X. That's the number of fish. Number of fish caught in, let's say, in a 6-hour period. Okay. And the P of X, that would be the percentage P of X, percentage of fishermen who catch X fish in 6-hour period again. While, of course, fishing in the, let's say, in the lake. Okay. So again, X, that's the number of fish caught in the 6-hour period, and P of X, that's a percentage of fishermen who catch X fish. For example, if X is 2, P of X is equal to 2, that would be percentage of fishermen who catch 2 fish in 6-hour period while fishing in the lake. Right, so we have the following probability distribution. So X is 0, 1, 2, 3, 4, or more. Okay, so X, again, that's the number of fish caught, and then P of X, percentage of fishermen who catch X fish. So percentage of fishermen who will catch like 0 fish is 44%, or 0.44. I'm going to use decimals instead of percentage. So 0.44. This is 0.44. This is 0.36. This is 0.15. 0.04. And this is 1%. So this is 0.01. Anyway, guys, so the questions are the following. Well, 1 minute just to finish the exercise. So we need to compute, first you need to compute the mean, mu. 2, you need to compute the standard deviation. Sigma, and 3, you need to find the probability that a fisherman, of course, selected at random, fishing in the lake, of course, catches 2 or more fish in a 6-hour period. All right, guys, I will let you think about this exercise, and I guess I will go over this on Wednesday. So again, guys, I will meet online this Wednesday, and yeah. So I'm gonna stop here. Thank you for listening, and good night, everyone. I'll see you on Wednesday.
Good night. Professor,
yes.
Hi,
yes.
I want to take a picture for the first, for the information in the tab because I came late. So I like to take a picture.
Well, I mean, actually, I'm gonna upload I'm gonna upload the recording.
Oh, okay.
I mean, yeah, I'm gonna upload the recording on YouTube so we can. I mean, you can check the video later. I guess.
All right. Thank you. Good night.
Sure.
Good night.
Good night. Thank you, guys. I appreciate it. See you next Wednesday.
Okay.